Hello students, welcome back. So in this session, I'm going to be talking about containers for data, list, tuple, and set. So set is an ordered mutable collection of elements. Ordered means that the elements in the collection, they maintain the order in which they were added. And I will show you through an example in a minute what do I mean by that. A list can contain duplicates. A list elements, they can be of different types. In other words, they are heterogeneous. They can be integer, they can be string, or they can be boolean, and so on and so forth. Then list, it supports indexing and slicing. So I'll show you in a minute what do I mean by these. Now use your list when you need to preserve order of elements or when you need to change your elements very frequently. And they are generally ideal for your general purpose storage and manipulation. So for general purpose storage and manipulation, you want to go with the list. Tuple. They are ordered and they're immutable collection of elements. They can contain duplicates. They're heterogeneous, just like your list is. They can contain elements of different type like integer, string, and boolean. Now, tuple also supports indexing and slicing. Now, tuples, they tend to be faster than list, important. So they tend to be ideal when your data remains fixed. That is, when you're not performing many insert or update operation, then prefer tuple over list. Use cases. Tuples, you want to use tuple when you want to create a fixed constant data structures. They're often used for read-only and hashable data. In other words, for example, like keys in dictionaries. Okay, they're ideal when your data does not change very frequently. So they are best in the case when you are not changing your data accidentally or frequently. Sets. Sets is an unordered and mutable collection of elements. They don't contain any duplicates. A set can have a different types of element as long as they are string, integer, float, or boolean. A set cannot contain list or a dictionary. It does not support indexing or slicing. Use cases. When you need to eliminate duplicates, use sets. When you're doing operations like union, intersection, differences, and these types of set operation, use set. When you have to check very frequently for membership, whether you want to check if something exists in a container or not, you have to perform that operation many times, then you want to prefer set. This is a summary of your set, list, and tuple. All right, let's start with examples. So I have this, let me just copy this, come over here, and paste it out here. All right, so the way you define your list, you use this square bracket. Tuple is defined using these round brackets. Names is defined using curly braces. Okay, so let's say I have a list of names: Tom, Ashwani, Patel, Shamlodia, Ashwani, Tom, Ashwani. And I print my names. And I also want to see what type of data do I have. So let's run this. And it prints out my list right there. Okay, this is my list. And as you can see that it's a class list right here. It's telling you it's a list right there. All right, let's do the same thing. Now we do with a tuple. Okay, tuple. Now, one thing I want to tell you about list, if you look over here, it preserved my order. Okay, I wrote Tom, Ashwani, Patel, the order in which I wrote. It printed my output in exactly the same order. All right, and also you notice it contained duplicates. So my list allowed me, when I printed my list, it allowed me to retain my duplicates. Same thing with tuple. Now I'm creating a tuple. I'm using round bracket, and it preserves my order just like your list does. And it can also contain duplicates. As you can see, it contains duplicates. So if I run this, it prints my elements like this. And as you can see, this is a tuple right here. Look at my parentheses. And it even prints the class. I print what type it is. It's printing, it's a type tuple. All right, let's do the same thing with set. Same data. Now I'm printing it with set. Okay, now if you look at your set, let me run this first. Now look at the output of your set. In the output, some of the names are gone. You see, actually the names are gone. Your content have become smaller now, and that's because your duplicates are removed. As you notice, Ashwani, Ashwani, Ashwani. There were 3 Ashwanis. Now there is only 1 Ashwani. Same thing with let's see, Tom. There were 2 Toms. They are gone. There's only 1 Tom. So duplicates are removed. And also look at your order output. Okay, look at your output. The order is not preserved. Your Patel, Tom, Shamlodia, Ashwani. Okay, it's not going to be exactly in the same order. So if I run the same thing, let's say I create another list. Create another list. Sorry, another set. And this time I create a set of Tom, Ashwani, Patel, and that's it. And remove these ones. Okay, let me comment this out. And now if I run this, and you're going to see Tom, Ashwani, Patel, Shamlodia. Patel, Tom, Shamlodia, Ashwani. The order is not preserved. You see, the order is no longer preserved. So be aware of this. That's what you mean preserving order. Okay, and the duplicates are removed too. Heterogeneous. All right, so this is my list of. Now in this list, I have an integer, I have a float variable, I have a float data as a matter of fact. So, and I also have a list inside of a list right here. Okay, and then inside this list, I'm also storing a tuple, and I'm also storing a dictionary, a set. I'm sorry, I'm also storing a set. So I have an integer, I have a float, I have a list, I have a tuple, and I have a set. And if I print this, it works just fine. So a list can contain elements of different type. It can contain integer, float, list, tuples, and set. Now let's look at tuple. In this case, I have a tuple, and this tuple consists of different types of elements. This is integer, a float element, a list element, and another tuple. So a tuple can contain a tuple and also a set. It contains a set, and I print it out. It prints just fine without any error. Now let's look at the set now. A set of integer, float, boolean, string. So this is my set. This is my set, and I run it. It works just fine. On the other hand, if I create a set of an integer, a float, and a set that contains, a list. Okay, so a set that contains a list. If I run this, it's going to give me an error because it does not allow you to store a list. A list is not a hashable. That's why. Okay, it's not a hashable. That's why it's not allowing you. Same thing. If you try to store a set inside of a set, same problem. An unhashable tab, you're going to get this error. Okay. Accessing elements. Now, how do you access elements in a list? Let me copy this. Print over here. Okay. Now in a list, your indexing starts with 0. Remember that. Your indexing always starts with 0. So if I have a list of numbers, and let's say my numbers are this right here. These are my numbers. All right. So these numbers could be anything. They could be age, income, your houses, how many houses you own. It could be anything. Okay. So if I try to access an element at index 0, this is index 0, index 1, index 2, index 3, index 4, and so on and so forth. So the way you access your list is through index. And index always starts with 0 in your list. So if I say numbers, square bracket 0, you use the square bracket to access an element and you specify your index over here. So if I type square bracket number square bracket 0 is going to give me an element at index 0, which is 10. It prints out 10. Now if I want to print the element at index 1, which is 30, it should give me 30, and it does. Likewise, if I want to access the element at index 3, index 3 would be right here, 70. 0, 1, 2, 3. This is your index 3. It prints out 70. If I want to have access to the last element, I'm going to say -1, and that's going to give me the last element, which is 50. If I want the second last element, I'm going to say -2. So you can go backward too. Access second last element, second last number. In this case, it's going to be 60. And if I run this, it's going to give me 60. All right. Slicing. Let me create some cells. Numbers. Let's say these are your numbers. Okay. I want, the way slicing happens is you have a start index, colon, stop index, colon, step size. This is the convention. You use a square bracket, you specify your start index, colon, stop index, colon, step size. If you don't specify your start index, but default is going to take 0. If you do not specify your stop index, but default is going to take the last index, which is the last position. If you don't specify your step size, but default, your step size is going to be 1. Let's say I want my numbers from 1, 3. Okay, I want from 1 to 3. So index 1 to index 3. That's what it's saying. So if I run this, let me comment this out. Now, if I run this, it's going to give me element from index 1 to index 3. This is index 1, 2, and 3. Now be aware, it's not going to print the 3. Okay, the index element at index 3, it is not going to print. It's only going to print up to index 1 and index 2, but it is going to stop 1 before that. In other words, the index 3 is where it actually stops and it does not print that element. Be aware of that. So it's going to slice from index 1 to index 3, or if it helps you understand, index 1 to index 2. All right, 30 to 60. Okay. Now, let me remove this too. Now let's say you want element from index 1 to index all the way to index 6 and with the step size 2. Now you're specifying your step size. Your step size is 2 right here. The step size, now you're specifying 2. So let's print this and it's going to print 30, 70, 20. And what just happened is this. First it prints 10. It prints 30. Okay, this is your index 1. Remember, it starts with 1. Index 1, then step size 2, right? So it's going to go 1 and 2. It's going to print 70. So it prints 30, it prints 70. And then it's going to go step size 2 again, because remember the step size is 2. So 1 and 2. Now it's going to print 30, and it prints 30 over there. Now it's going to go up to index 7. So this is 0, 1, 2, 3, 4, 5, 6, 7. This is the one. So when it comes to printing, okay, so it's going to go 1, 2. But remember, it does not print this one. Okay, it actually stops before that. So it's just going to stop right there. So it's going to print 30, 70, 30. 30, 70, 30. Okay, now you want to slice the first 3 elements. So one way to do, you can say numbers colon 3. Now if you don't specify this number in front, remember by default is 0. So there is a 0 over there if you don't specify. You can also tell 0 if you want to, or just leave it blank. And that's going to print the first three elements: 10, 30, 60. Your first three elements: 10, 30, 60. What if you want to print? You want the slice from index 2 all the way up to the end. So remember, you're specifying your 2, right? You're specifying your start index, but you're not specifying your stop index. So by default, your stop index is going to be the last position. That's your default position. So it's going to go from index 2 all the way up to the end. And my step size is going to be 1 by default. So it's going to go through each one of the element and give you every single element. And you can see 60, 70, all the way up to 50. Starts with 60. Starts with index 2. All right. Now you want to begin from all the way from beginning to the end. I'm not specifying this. I'm not specifying this. So my start index is 0. My stop index is the last position. And my default step size, in this case, I'm not using default. I'm actually using 2 right here. So it's going to print from beginning all the way up to end with the step size 2. And there you go. 10, 60, 50, 60. So it prints out 10. The next one it prints out is 60. Remember, step size 2. Step size 2, 50, then step size 2, and then 60. It prints out each one of them. Now, you can also reverse these elements. So you can just do colon colon minus 1. It's going to print the element in reverse order. Tuple. Same principle applies to tuple too. Whatever we have done with list, you can do the same thing with tuple. Same concept with tuple. If I run this, it's going to print exactly the same way. Number 0, element at index 0. 10. Numbers index 1. It's going to be print element at index 1. This is going to print the element at index 3, which is 70. This is going to print the last element, 50. Same concept. Slicing. Exactly same concept as your list. So numbers are like this. Let me remove this. So these are your numbers: 1 colon 3, okay, and 1 colon 7 colon 2, index 1 to index 6, all the way up to the step size 2. And if you run this, it's going to print exactly same result as the one on the top. The only difference between this and the previous is that I'm using tuple notation over here. I'm using round bracket, and the previous one there was a square bracket. That was a list. Other than that, the concept of slicing is exactly same. Set. Set does not support indexing. Important, the set will not support indexing. So if I have a numbers, same type of numbers as on top, okay, age, income, and this could be any data, okay. And if I print my numbers, it's going to work just fine. It's going to print my set 50, 70, 10, 60, 30. As you can see, it has removed the duplicate. Some of the elements are duplicated, like 50, 50, they're gone. There's only 150 now. And the reason this indexing does not make sense is because it is removing duplicates, and because it is removing duplicates, which one, when somebody says print me element at 0 or element at index 0, a set, that does not make sense in your set. So that's why it does not support indexing. Now if I try to run this, it's going to give me an error: set object not subscriptable. Okay, so these concepts would not apply to sets. Any one of these concepts, they would not apply to sets. Neither this and neither one of these operations. None of these operations will apply to set. Okay. All right. Now list and sets are mutable. A tuple, on the other hand, is not mutable. List and sets are mutable. A tuple is not mutable. List. So let's say you have numbers 10, 20, 60, 20, like this. Okay. Let me comment each one of these lines out. There you go. And let's run this. So in this case, I'm changing an element at index 2 right here. I'm printing my numbers first. So I print my numbers. Okay. And then I try to change. I actually change the element at index 2, which is right there, index 2. And I change it to 25. And then I print my numbers again. And as you can see, the numbers have changed. This is 25 now. Okay. So if I make this thing like this, there you go. Let's run this again. And now you can see. Now you can see comparison side by side, 60, 25. They have changed. Okay, so this way you can change the element. A tuple, on the other hand, will give you an error. If I run this from here, if I run this and I try to change the element, okay, I'm trying to change the element right there, same way as I'm doing with the list. I'm using tuple, and if I try to do that, it's going to throw me an error. Tuple object does not support item assignment. So be aware, tuple, you cannot change the elements using indexing. Okay, set. A set can be changed, but not through indexing. It requires something else, and I'll explain you later below on how to do this. Methods of list. Let's create some cells. These are my numbers. I want to see all the methods that are available inside my list. So the way you do is you type this dir numbers like this, and that's going to give you all the methods. These are all the methods that are present inside your for a list. Now the most important ones are these ones right here, the last ones, the ones that you don't see underscore underscore like this. Those, the ones that you see, the one that you do not see underscore underscore, those are the important ones, these ones right here. Okay, so let's deal with them. By the way, you can also look at the documentation for each method. You can just type print help numbers, and that's going to give you documentation for each one of them. If you run this, it's going to tell you about each and every method, what add does. If you come down somewhere over here, you're going to see what append does. It appends the object to the end of the list. Remove, it removes all elements from the list. Count, extend, index, uh, pop, remove, reverse, sort. It gives you all these different methods, and it all tells inbuilt method, and also tells you what these methods they do. Very helpful. Okay, let's look at few of them. Let's start with the list first. Okay, append. So these are the few ones: append, clear, copy, count, extend, index, insert, pop, remove, reverse, sort. These are the like important ones. So let's look at few of them. Let's say you have a numbers like this, and you want to append at the end. Append means you want to add a number at the end. So the command is, or the method is dot append. So after I run this, okay, it's going to append 70. Let me run this, and there you go. So numbers after append is right there, 17. You can see 17 has been added right there. Okay, now let me comment these lines out. There you go. Run it again, and there you go. Numbers after append is this right here, 17. So this was my original list, and now I added 17 at the end. Okay, now let's insert based on an index. I want to insert element 25 at index 3. So index 3 would be right here. Okay, now let's do that. Now when you insert the element at index 3, what happens is that these elements, okay, these elements, they actually get moved on this way. So index 3 would be which one? 0, 1, 2, and 3 right here. Okay, so this is where your element 25 gets inserted, and then 40 and 50, it gets shifted towards right hand side. And you can see 10, 20, 30, 25 gets inserted over there, and 40 and 50 gets shifted towards the right hand side. You can also remove elements. Let's say I want to remove an element 50. If you run this, it's going to remove 50. As you can see, this is my list right here, and I remove 50, and now 50 is gone. You can see 50 is no longer there. Okay, you can also remove an element based on an index. You want to remove an element on which is located at index 2. So this is my index 1, sorry, index 0, index 1, and index 2. Now if I run this, numbers after pop, 30 is gone, and you can see 30 is no longer there. It's gone. finding an index of an element. Okay, so let's say you have numbers 10, 20, 30, 40, 50. Let me comment these ones out. All right, these are your numbers. Oops, sorry. Let's run this. And this is going to print the numbers at index 30. Sorry, the number, yeah, the number is going to print me the index of the number 30. Sorry, excuse me. It's going to print me the index of the number 30, and the index of the number 30 is 2. So 0, 1, 2. It prints me 2 right there. This one right here, I want to count how many 60s are there. So let's say I have a list of numbers 10, 20, 60, 30, 60, 40, 60. I want to count how many are there. The method for that is dot count. That's going to return all the count. 3. There are 3 60s. If I type something else, let's say 600. Let's see what it does. 0. There are no 600 over there. 60 and works just fine. Sorting. You can also sort the numbers. So let's say I have these numbers minus 6, 10, 20, 30, 25, 40, 70, and I want to sort them. Use this dot sort, and that's going to sort the numbers. And after sorting, you got these numbers right here. Reversing. Maybe you want to reverse the numbers. You have these numbers and you want to put them in a reverse order. You can do that too. You can do dot reverse, and you can see it prints 17 first, 40, 25, 30, 17, 40, 25, 30, 20, 10, minus 6. It reverses the order of the numbers. That's all. It does not sort it, it just reverses it. Method of tuples. Same thing we did with that list, we do the same thing with tuples. These are your numbers 10, 20, 30, 40, 50. And if you want to see what the tuple can do, or what are the different methods of tuple, you can type dir numbers. When you run this, it's going to give you all these. The most important ones are the ones without the underscore, which is these two, count and index. These are the important ones. If you want to see what these do, just type print help numbers. Click on this, run this, and if you come down and let's see, you will see index. What index does, returns the first value of the index. Count returns the number of occurrences of a value. Okay, so it gives you kind of like a helpful documentation on each one of them. Let me comment this out, run this. Okay, let's look at them. Let me create few cells. All right, so let's say I have my T tuple 10, 20, 60, 30, 60, 40, 60. I want to count how many 60s are there, and I print my count. All right, and it gives me count is 3. This is my first print. The second one, I want to count how many 600 is there, and I print my count. It gives me 0. There are 0 600s. Index. I want to print the index of my element 60. I want to find the index of the element 60, where my 60 is located, and it gives me the index. The command is, the method is t.index60. And I print my index, it gives me 2. You can see 0, 1, 2. Now remember, there's another 60 over here. There's another 60. It is always going to get the first index. So if there are multiple values, it's only going to get you the first one, the first value, the index of the first value. Methods of set. Same thing. So these are your numbers 10, 20, 30, 30, 60, 40, 60. You want to see the what are the different types of methods you have? You can type print dir numbers, and that's going to give you all the important ones. Now, the important ones are these ones towards the end right here. So dir will give you all the methods, and the important ones, the one that you will be dealing with, would be the ones without the underscore, which are these ones. Out of these, the most important ones are these ones: add, clear, copy, difference, intersection, union, update, remove, and so on and so forth. These are the important ones. So let's look at some of them. Rest of them you can look at your free time. Add and remove elements from a set. Sets are mutable. You can change the elements of set. So let's say we have a guest, Sarah, Wutzberger, Connor, Shamrodia, and we want to add a Ravinder to that. So the way you add is using dot add. Okay, it adds a guest. Let me run this, and there you go. You can see Ravinder has been added over there. Now I want to remove Connor. Okay, so I do guest dot remove Connor, and then I print my guest again, and you can see right here Connor is gone. Union, intersection, differences. I have a I have two class, art class and gym class. Alice, Bob, Charlie, Zena, they're inside art class. Bob, David, Zena, and Geeta, they're in gym class. I want to find, let me comment this one out, or actually let me just remove this. I want to find all the people that are in art and gym class together. So the way you do, there's a function called or method called union. So you say class art dot union class gym, and that's going to give me people who are in art class and a gym class. Another way to do the same thing is using this operator right here. Okay, this is called OR operator, and that gives me the same result. Okay. Likewise, you can have intersection. You can have intersection. You can have differences, and you can have difference as in like class art minus class gym. So let me explain you through a diagram. Maybe that will help you understand. So let's say I have these students. Okay, so in art, this is my art class, and this is my gym class. In art class, I have Alice, and I have Bob. Actually, Bob is both in art and gym, so I'm going to put this over here. And Zena is in both classes. All right, and then you have Charlie. So Alice, Charlie, Bob, Zena. These are in your art class. In your gym class, you have Bob, you have David, so let's call it D right there, and you also have Geeta, G. Now, all students who are in art and a gym class would be A, C, B, Z, D, G right there. You see that? And this is how you came across this elements, these set right there. Geeta, Alice, Zena, Bob, David, Charlie. Okay, so it's not going to repeat Bob twice. Okay, Bob is counted only once. Same thing with Zena. Now you want to check how many people are in both classes. In this case, you could tell that Bob is in art and also in gym, and Zena is also in art and she's also in gym class. So in this case, your Bob and Zena, they are in both classes. This is your intersection, and you give the intersection answer, which is right here, Bob and Zena. You can use intersection, either this command, this method, or you can use address operator right here. Okay, they both give you the same answer. Difference, you want to find people, or you want to find students only in the art class and not in gym class. So basically what you're doing class art minus class gym. So you're finding a difference between class art. From class art, you take away all the people who are in the gym class. So class art dot difference class gym. In this case, you're only going to get these people, A and C, Alice and Charlie. And you get Alice and Charlie. Okay, then you want to see other way around. You want to see class gym minus class out. Okay, this was class out minus class gem. Okay, this is class gem minus class out. So in this case, you're going to be having these elements right here. Okay, this would be David and Geeta. David and Geeta. This one gives you David and Geeta. You can also check if the elements are disjoint or not. So for example, you have A equal to 1, 2, 3, B equal to 4, 5, 6, C equal to 2, 4. And you want to check if there are any common elements between A and B. So it gives you true and false. In this case, A and B, okay, there are no common elements between A and B. So it gives you true. False for this case because 2 is common between A and C. If you look over here, A and C, 2 is a common element. You can also check if one element is a subset of other elements. So ABC is this. Is B a subset of A? It's going to print true because B is part of A. Is A subset of C? True because all elements of A are in C. And likewise, if you look at C is subset A, in this case is false because 4 is not in A. If you look at your element 4, this is not present inside your A. Membership. You may have to check if an element is present inside a container. So let's say this is my list of numbers 10, 20, 30, 40, 50. I want to see if 401 is in numbers, and I print my B, and that's going to give me false because this is not present. On the other hand, if I make it 40, is 40 present inside my numbers? Yes, it is. I can do the same thing with tuple. Tuple also does the same thing. It allows you to do that. In this case, it prints false because 401 is not present inside this. You can also do the same thing with set. Run this. In this case, is 401 in numbers? Nope, it is not inside this set. Oops, let me make this thing a set. Come over here, and there you go. Run this, and there you go, false. Let me fix that over here too. Okay. You can also find minimum, maximum, sum, or length of a containers. So let's look at a list. I have a list of numbers, okay, and I want to find minimum, maximum. In this case, minimum, maximum, sum, and length. Okay, length. So this is my numbers. The way you find minimum is min. That's the function right there. You want to find the maximum, type max. Find the sum, type sum, and if you want to find the length, you type length over here. And it gives me each one of the numbers: minimum, maximum, sum, and the length. And this way you can calculate the average. Your average is basically sum of your numbers divided by your total numbers. And that's going to print, I print my average. The answer is 28.33332. You can do the same thing with a tuple. So this is my tuple. This is my tuple, and I'm doing exactly the same thing now. And it's going to work just fine. It prints the same thing. With the set, same thing. Let's do with the set. And I run this. And look at that. Everything is same except my count. Look at these numbers. Okay, look at 176 and 28.33. In this case, it's giving me 150, 5, and 30. And the reason these numbers are different is because set does not contain duplicates. You see that there are when I print my numbers, it has removed some of the numbers. So there's a 30, 20, and 10, 20. You see there's 20 right there. There's a 20 present and there's a 20 present. But when I print my numbers, 20 there's only appearing once. So when it's calculating the sum, it's going to calculate for only this one. It's not going to consider the duplicate. In this case, it was considering duplicates. 20 and 20 was appearing twice. So it considered duplicates. A list and tuple will consider duplicates. A set will remove your duplicates. It will only contain the unique numbers. That's why your sum, your length is different. And that's why your average will come out to be different. Okay, thank you, gentlemen.